Hello. In this video, I continue the Introduction to Coding Web Games using HTML, CSS, and JavaScript series with Part 7. In the previous video, we reanimated our objects and added some boundaries to keep them within our canvas. We then added a function to check for collisions between our rectangle objects. In this video, we're going to add a hero to our game and learn a bit more about object states. All code and the sprite sheet used in this video are available for download at the link provided below. So let's begin. If you'll recall, we left our game in this state with the aliens bouncing around and flip-flopping, and then when they collide, they exploded. We want to take this action off. This was just a temporary placeholder action, and we want to actually have them do something different when they bump into each other. Instead of explode like that, we want them to bump off of each other, to just kind of, bump into each other and go the other direction. So in order to do that, we're going to have to add a little more logic, or a little more to our hit test rectangle function. And right here underneath var hit, we're going to add another variable, and this one we're going to name TBLR, as in top, bottom, left, right. And we're going to set that equal to an empty string, so just empty quotation marks. And we're going to put a string in there later that'll tell us whether we've been hit at the top, bottom, left, or right. So down here, the only place in hit test rectangle where you set hit to true, we need to determine if we've been hit at the top, the bottom, the left, or the right. And in order to do that, we need to check a few more things. So there are 4 combinations of a positive VY and a negative VY and a positive VX and a negative VX, and we need to check all 4. So the first one we're going to check is if VY is positive, meaning if VY is greater than or equal to 0, so that means it's positive or 0, and don't forget your ampersand, we need to check that Vx is also greater than or equal to 0. So this means both Vx and Vy are positive. And if that's the case, we have a little bit more logic, because this means you could be hit on either the top or the left, kind of your top left quadrant there. So we need to determine, is that the top or is that the left? So we check, and what we do is we compare the difference between combined half heights and math.absolute of Vx. So you write combined half heights minus math.absolute value of Vx, abs, math.abs. And we need to check and see if that is greater than or equal to the difference between combined half widths. Okay, so my brain broke here for a moment. It's when it's the Vx, when it's on the x-axis, you need to do the widths. And then when it's the y-axis that you're checking, you need to do the heights. But I put both heights or widths here, and I'll come back and fix it in just a moment. Just know that for the second statement, you need to check and see if it's greater than or equal to combined half heights minus math.abs_vy. See, there I go. So make sure you type it out just exactly like you have it here. Combined half widths minus math.absolute value of Vx greater than or equal to combined half heights minus the math.absolute value of Vy. Okay, so if that is true, this means that you've been hit on the left-hand side of your rectangle. So we can set TBLR to a big old capital L, meaning you got hit on the left. If this is not true, however, and that means it's the other way around, and you got hit on the top of your rectangle, and we want to do something different, then, whether or not we get hit in the top or the left will tell us which direction we're going to bounce off. Okay, so there's another combination. Then in this combination, you're checking to see if Vy is still positive. So Vy is still greater than or equal to 0. And I momentarily got it out of my parentheses. Plus, you'll see I put a space in between the greater than or equal to sign. That's a big no-no, and I'll have to come back and fix that in a moment. So I'm checking to see that that Vy is greater than or equal to 0 and Vx is less than 0, meaning it is negative. So I've got a positive Vy and a negative Vx in this one. But this is still the same logic. I still check the same exact logic here, except now this time instead of left top quadrant, I'm in the top right quadrant. So this is either getting hit on its right or its top. And you can just change it like that, and that'll work. Now we need to check the third combo, and that would be that if Vy itself is negative, meaning it's less than 0, and Vx is also negative, meaning Vx is also less than 0. In this case, again, it's the same inner logic, except this time you've been hit in your bottom right-hand quadrant, so the top changes to a bottom and the left changes to a right, just like that. Basically what you're checking is you're just checking to see if the center of one circle is closer to, is like within the x coordinates or within the y coordinates, and that tells you obviously if it's been hit on the sides or the top or bottom. Now the final one here is if Vy is less than 0, meaning negative, and Vx is greater than or equal to 0, meaning positive. So in that case, you've been hit on the bottom left. And you can keep left the same and change the top to bottom. So there you have it. There's 4 scenarios broken down into their sub-scenarios. So now, here where you return hit, you don't want to just return a Boolean anymore. Remember, hit is just a Boolean, true or false. You want to return an object. And objects get curly braces. And objects have key value pairs, like we've learned. And the key name, the first key name is going to be hit. And then we're going to give that a value, put a colon, and we're going to give that the value of hit. So hit's going to equal hit, comma, and excuse my cursor there. The second key name is going to be TBLR, colon, and we're going to pass it the value of TBLR, just like that. So now you're passing an object with 2 key pairs, hit and TBLR. So everywhere you call that, which is down right here, now hit isn't, it's no longer just a Boolean, it is an object. It has a Boolean as its first key value pair, and that you got to call the key name, so you say if hit dot hit. Now we're back to being a Boolean. We can comment out this. We don't want to do this anymore. This is where we destroy our aliens. So let's not do that. That was just a placeholder. What we will do instead, though, is we will check to see where this alien has been hit. So if hit.tblr, because remember that it's a key now, if that is equal to t, that means we've been hit on the top. And if our alien has been hit on the top, it means it must have been traveling upwards, and we want it to go down. So in order to get our object to go down, we change this dot up to false, because obviously it was true if it was traveling up. So we say this dot up equals false. Conversely, if our alien was traveling down and it got hit on the bottom, and that would make TBLR a B, then we know it was traveling down and we want it to go up. So we say this dot up is equal to true. Same for left and right, but slightly different. In this case, if you're hit on the left, you were traveling to the left, and we want you to travel to the right, so we turn your left false. So this dot left is now equal to false. And then again, if you got hit on the right, you were traveling to the right, I want you to go left, so this dot left will be set to true. Okay, now if we've done this, instead of blowing up when they hit each other, they should just kind of bounce off of each other. And most people will notice, oops, they still exploded. Well, I hadn't refreshed it yet, but now I have an error. Let's see. I have an unexpected token on line 99 of YouTubetutorial.js. So I go find line 99. Okay. That's where I'm learning that I put that space in between the greater than equal to operator. You cannot have spaces in your operators. If you're doing greater than equal to, you have to have it all one string, one statement. All right. Okay. So now if we've done it right, when they hit each other, boop, there we go. Instead of exploding, they just kind of bounce off. But people will notice there's something fishy going on. They're kind of like moving twice sometimes, and that's because they've gotten so close that even though they move away from each other in the next frame, they're still touching, and it registers as another hit. I'm going to be honest, for my purposes for this game, that's fine by me. I don't mind whatsoever. You'll also notice that when they're touching, when they're actually in collision, they stop flip-flopping. So we're going to go and we're going to fix that in a moment. And we're going to deal with the states. We're going to make the states of our objects a little more robust. I forgot exactly which one I started off on first. Okay, so the flip-flop problem. When they touch each other, they stop flip-flopping. That's because this code down here, if this dot state is not equal to 0, this dot state equals 0, that part right here that makes them flip-flop, I'm only doing that while they're not touching. So I need to come up here and, well, this is one way. I could put it just the same thing up in here so that it makes them flip-flop whether they're touching or not. And I'm showing you that just so you can see that this would work. And you'll see they still flip-flop, but now they'll flip-flop even if they are in collision with each other. See, they keep flip-flopping. But now I have redundant code. I have the exact same code here and here. So what you can do is we can do something called refactoring. And we can pull this code out physically, like I hit Control X and it cut it out, but it also copied it. And then I can come up and I can make a function, and we'll call this function flip-flop. And our function needs to tell an alien to flip-flop. So let's break this. Say you need to tell us what alien we are flip-flopping. So we take it as a parameter, and we just put that code in there. But now everywhere it says this, we're no longer calling it from within one of the objects. So we have to tell it this alien. So switch out this with alien. Okay, so what you've done now is you refactored your code and you put it into a function. So everywhere that you had that code, you could just call this function. So I'm copying the function name, and down here where the code was, all you have to do is just call that now. But you can't say alien. Yeah, and this is calling from within an object, so you could say this object that is calling, and replace the other redundant code with the exact same thing there. And now your code's a lot more readable, more easily read, and is less redundant. And it does the exact same thing. And that's what refactoring is. It's when you change the code, but you don't change the workings of your program. If you change the code and you change how the program works, well, that's just coding. But refactoring is when you change the code like I just did, but nothing changes in your program. Okay, now we're going to deal with states, because we kind of call states on two separate occasions. We call the actual state and we set it to 0. We hard code it to a number, but you know how we don't like hard coding things in when you're coding. So what we're going to do is we're going to make it more robust by going up into image object and making every image object have certain states. Now the base states, which we're going to start here, are normal. So you give it a key name of normal, colon, and we'll give that a value of 0. So now image object dot normal equals 0, comma. The next state is hit, because we're checking to see if a lot of these are hit. So we're going to say hit is going to be equal to 1, comma. Don't forget your comma. The next attribute is the actual state itself. And we're going to say that this state is going to have 0, meaning it's equal to normal. So state right now is 0, normal is 0. That means our state is equal to normal. So everywhere you actually deal with the state, or the hit, because we've also made it a state now, you can actually change that. But first, temp alien, we want to give it 2 more states. We want to give it temp alien, specifically temp alien, none of the other objects. We want to give it a flippers up state and say that temp alien dot flippers up. And we can't use 0 or 1 because we've already used those for normal and hit. So we have to go to at least 2 on this one. So now temp alien has a flippers up state that is equal to 2, and we want to give it a flippers down state equal to the next number, 3. And the reason we only did that in the make alien function is because you don't really want to be giving your hero a flippers up and a flippers down. So here where it said hit equals false, we can actually now say temp.alien.state is equal to temp.alien.normal. Or you could have just written 0, but this is a nice way to be able to read it. If a human comes by and says, oh, okay, now I know the state is normal. Now up here where we did with the state, instead of saying 0, we don't have to put 0 now. We can say alien.flippers up, because that's really what we're checking. We were checking to see if it had its flippers up, and if it didn't, we put them up. So now we can just say if alien.state is not equal to alien.flippers up, then put them up. If it is, we want to go aliens.flippers down. And that's just going to change the state of your alien from flippers up to flippers down now, instead of from 0 to 1. Here, where we call this .hit, that's a form of calling the state. So now we could say this .state does not equal this .hit. Again, writing it this way makes it just a little easier to tell what's going on. You know, okay, so I'm changing the state to hit, or I'm checking the state against to see if it's not equal to hit. And here, same thing. And actually later on I realized that I don't even need this part, this statement, this .state is not equal right here in this else statement, but it doesn't hurt anything for now, and I don't realize it till the end, so you can leave it in, you can leave it out. Okay. Again, we refactored. We changed the code, but we didn't actually change anything. We just made it more robust. Now we can add as many states as we want and keep track of them. Okay, so next, we're being invaded. Let's give our program a hero, and let's create a program or a function called function make hero. And we're going to do something different with this make function, because usually we make a temporary variable and then create our object within it. But for the hero, we're going to want to use that outside of our variables. So we're going to come all the way to the top, and we're going to create a variable called hero. We're just not going to set it to anything. We're going to leave it alone. And that means we can use it in all these functions because it's got a global, what's equivalent to a global scope. So now, in our make hero, instead of saying temp hero, we can just say hero is equal to make image. We don't have to pass it anything except an x and a y, because you always want to at least give it a dynamic x and a y coordinate. So we'll say hero is equal to make image. And you now know that we have to pass it the xy width and height in relation to our canvas. And then you need to pass it the source width, source height, source x, and source y in relation to the image itself. And I think for now I'm just going to write some placeholders here so that you know what goes there. But I want to deal with the source x, source y, source width, and source height first. And I'm going to make my hero the same size as my alien. On my canvas, they're both going to be 60 by 60. So now let's deal with the source x, source y, source width, and source height. And let me show you where I'm getting this picture from. It's going to be in the upper left-hand corner of my sprite sheet. It's the very first top picture there. So that means its corner is at 0, 0, as always. The upper left corner is 0, 0. And it's 50 pixels wide by 50 pixels tall. So this is an easy one. The source x and source y are just 0, 0. And the source width and source height are 50, 50, just like my aliens. And the image I want to pull this from is, again, sprite sheet. So I send it the image of sprite sheet. And I need to give it a type now. And this is neither a background nor an alien. So I'm going to give it its own type of hero. Alright. Now we need to actually call make hero for it to show up on our canvas. And I like to call the hero, I like to make the hero right after I make the background. So when the program loads, it makes the background and it throws the hero on there before it builds anything else. So we call make hero, we need to send it an x and a y. I want my hero to start the game in the very bottom center of my canvas. So we send it, we need to give it a little bit of math. And for the x coordinate, if you recall about rectangles, to put it in the middle, you send it the canvas, not center, canvas dot width divided by 2, and make sure those are in its own little parentheses. And then you subtract from that half of your rectangle. And since I know that our hero is going to be 60 pixels wide, I can just do half that, which is 30. Okay, now for the y coordinate, it's a little bit different because we're not going to the center. We want to go all the way down past to the bottom of our canvas, but then pull back up the height of our image so that because if we go all the way down, it'll be off of our canvas, and then we need to pull it back up onto our canvas. So we say canvas.height minus, and then the full height is 60, so I just wrote 60. And I misspelled canvas. I'll come back to fix that in a moment when it tells me I have a problem here. I always inspect first, and because it'll tell me exactly where my problem is. Right there, it's saying canis is not defined on line 79 of YouTube tutorial.js. So I find line 79, I find that, and I put the V in. There we go. Now we have a hero in the very bottom center of our screen. He doesn't do much though, he just kind of stands there. He also doesn't, there's no danger because nothing happens to him when he gets hit by the alien. So we're about to change that. We're going to give our hero, down in make hero, we're going to give him an update function. And we're going to check him against all the aliens in the sprite array, but only the aliens. So down here, underneath where we make the image, we need to say hero.update. And I've messed it up for just a second. It says hero.update is equal to function, and functions get parentheses in case you want to take some parameters, but no space between them. It doesn't matter about the space there, but I don't like space between them. And then curly braces, semicolon. In that curly braces, again, we're going to check it against all the aliens, so we need to do our for loop, where we call for sprite of sprite array, but we need to also, within that loop, double check to make sure that we're not checking, that we're only checking against aliens. Oh, I fat fingered my keyboard there. So we need to say if sprite does not equal this. Okay, so at first I put this there, sprite does not equal this, but then I realized that this is a shot and none of the shots will ever be hitting each other. So we don't need the sprite does not equal this. We can just say if sprite.type is equal to alien, because if it's not an alien, then we don't want to check it. We don't check the shots, we don't check the background, we don't check the hero. We only check the alien. So this is all you need here for now. I think you'll also need and this dot hit, this dot state does not equal this dot hit. Just because once the hero has been hit. Oh, I am doing hero. Sorry, I said shot earlier. That's later on. My brain got ahead of myself. We're doing the hero here. But we only have to check to make sure that the type is alien, because if it's not, then it'll be a hero or a background. Okay, so sorry. Moving on. We want to check that it fits hit, so we create a variable called hit, and we set that equal to hit test rectangle, and we send it this and sprite, R1 and R2. And remember, we're receiving a object now, so we have to check hit dot hit, and we have to see if that is true. And if it is, we want to do something. For our hero, if he gets hit by the aliens, that's going to be game over, man. So we're going to do something called destroy hero. And we don't need to pass it any parameters because we have a global hero variable and we can just use it. So we don't have to pass it anything. We know exactly, when we only have the one hero. so we know which hero we're talking about. Also, you want to set this dot state before you even destroy that hero. Set this dot state equal to this dot hit. And that means that this hero has been hit. And it won't, if you don't set it to hit, sometimes it'll hit, and then another frame will go by and it'll register another hit. You have to tell it, no, I've already been hit. Okay, so now we're going to build our function destroy hero. Up here above, right below destroy alien, write a function called destroy hero. And first thing we're going to do is we're going to change the hero source X. And we want this explosion. So we're going to have to go over the blue explosions for the alien. And we go to 50, 100, 150, 200. 200 is our source X. And I misspoke. I meant to say the blue explosion is for the spaceship. So we set our source X to 200. And then we can just do the same thing that we do in destroy alien. So you can copy paste that set timeout. But instead of alien, we're going to put our global hero in there. And that will splice it out of the hero array. I mean the sprite array. Okay, so now if we've done things correctly, if our hero gets hit, he should blow up. Let's see here. There you go. So now we need to give him a way to avoid getting blowed up. Boom. What we're going to do now is we're going to bring in some controls to our game. Just a simple left and a right, and we're going to bring in the spacebar, but we're not going to use it immediately. We'll use it later. So at the very, very, very bottom of your program, all the way down where you called the onload, which we don't need anymore, but we are still going to do something with the window. We're going to call the window, and we're going to add an event listener to it. And remember, event listeners are listening for a very specific event, and we tell it what to listen for. And we're saying listen for a key down, meaning somebody has pressed a key down on their keyboard. And every time somebody presses a key down on their keyboard, the key down event listener is called. And we tell window to call the key down handler function that we will write in just a moment. And don't forget your false at the end of it so it doesn't bubble. But now that we have a key down, we want to do the exact same thing with key up. So wherever it says down, change this to up. And this, change that to up, capital U. So now we need to actually make these key down and key up functions. The key down handler and the key up handler function. So right above there, you can type function key down handler. And event listeners, when you write the handler for them, you like to accept the event because it was some sort of event that triggered this function, and you can accept that, and it'll tell you what the event was, and it gives you a lot of information about this event. You don't have to write the whole thing out though. You can actually just say EVT, and you know you mean event. But first, there is something that you need to do, and usually an event has a default action that is associated with it, and you don't want that to occur. Like if it's the enter button, then it'll submit something, or you don't want it to do that. So what you want to do is you're going to write event.prevent default with a capital D. If I move my cursor there, you can see I have a capital D. Next, just for now, just for our purposes, write console.log, and we want to log something called the event.keycode. And what that's going to do is every time you press a key down, it will log the code that is unique to that key. It's like an ID. You can just copy paste and change everything to up for the key up handler, except we don't want to console.log anything. So now we have a key up and a key down handler, and when we press a key down, it's going to log the code. And we need those codes to proceed further. So we come over here and we inspect, and you either inspect by, if you have a Chromebook, it's alt-click on the page, and if you have a Windows, it's right-click on the page, and then select inspect, and find your console, the console tab up top. So now, if we refresh and we run the new code, every time I press a button, it'll tell me something. And what you want to press first is the right arrow. 39 is the key code for the right arrow. You want to make a note of that. Well, you don't have to. I make a note of it for you. The left arrow next is 37. And I also said you want to hit the space bar. And that gives us a 32. So right arrow is 39. Left arrow is 37. Space bar is 32. And we can use that in our code now. So down here in key down handler, we're going to add something that we have never done before, and it's called a switch case. And it's a very easy way to go through a bunch of cases without having to write a heck of a lot of if-else statements. So instead of writing all those if-else statements, we're just going to write switch, and we give it some parentheses, and we're going to check something for the switch. And what we're going to check is just what we've been looking at, the event.keyCode. And give it parentheses. So now, in a switch case, it'll do things in certain cases. Like, you write case. And if it's the case that the event.keyCode was 39, meaning case 39, hit a colon, go down to the next line. You want to do something. I'm going to make a note here, just by commenting out this line, and then I'm going to say that this is the right arrow, just so I don't forget. So if it's the case that it's key code 39, I want to say hero.write is equal to true. Now hero.write doesn't exist yet, but it will in a moment. Just set it to true here, and we'll make it right in a moment. Then for every case, you have to break. You have to have a break statement, and that breaks you out of your switch statement. So for the next line, the case is 37, colon. That means the left arrow has been hit. And in that case, you want to say hero.left is equal to true. You want to hit left to true. So we already have a left, but now we're going to have to add a right to it. So we'll do that in just a moment. I begin with the next case, the case 32, just like you see here. And I even make a note that this is the space bar, but then I realize that I did not put the break statement in 37, and it is absolutely necessary, because if you don't break out of the switch case, it'll just go down to the next case and run that as well. So it would do the left arrow, and then it would do also whatever I tell it for space bar, which for now is nothing. Don't worry about it just yet. Okay. And every good switch case has a default case, and you write default colon, and then down there, right now all you do is break out of your switch case, so you just hit break. But this default will be what will run if it doesn't fall into any other. So let's say like 45 came up as a key code because you're hitting other buttons. Well, then it would just hit the default and just break out of my switch case and not do anything. So we can just copy paste that directly into our key up handler, except everywhere it says true, you want to write false. You see I write left here. Also, we don't need the space bar. So this, again, bear with me please. It will come back to bite me in the bum. I didn't mean to write left. I meant to write false. And I'm going to shortly wonder why my guy doesn't stop moving. Okay, so now, under hero make image, we need to give it that right attribute. So we say hero.write is equal to false. Now it has an attribute named right, and it's set to false. It already had one named left, because if you recall, when we make an image object, we already set it to left. So I also make another mistake here. Go ahead and write what I'm writing, and put an else to that if statement, and tell it that if this dot right, meaning I want it to go right, well, whenever you want something to go right on your screen, you add to its x coordinate. So this is what I'm going to do. You say this dot x, and then plus equal, meaning take the x that's already there and add something to it. So this dot x plus equal 5. 5 is a good number. And same for the left. You can just say if this dot left is true, except not plus equal 5, this time you're going to want to minus equal 5. So if this dot left minus equal 5. Now what I've done wrong is I put this up in the for sprite array loop. So my guy, if I hit left, it's just going to zoom off the screen. Woo! There it goes. To the right. And then I realized, oh my goonies, I put it in the for loop. So I need to pull it out of that for loop. So all I do is I highlight my code and I control X and that cuts it out of there. And then make sure it is outside the for loop. Also, we don't need this else, so you can just erase that. So you go outside the directly outside the for loop, which is right here. Now it will go at a more reasonable pace to the right and to the left there. Except I suddenly realized that when I do key up, it's not setting the things to false, and I'm like, why is it not working? So I go and I check my key up, my key down, and I realize that I'm setting them to left instead of false for some reason. I'm like, oops. Okay. So now when you lift the key up, it sets the right and the left to false and allows you to go right and left. And you can see there, now when I hit the left key, it goes left, and when I hit the right key, it goes right. But it also goes off the screen. And to fix that, all you have to do is go up to your logic where you tell it to go right or left in the where you make the hero, and say if this dot right and double ampersand. And remember to check to see if the right side is touching the right. You could say this dot x plus this dot width. That's the right side of your image. And then just check to make sure that it's less than the right side of your canvas, which is just the canvas dot width. So you say this dot x plus this dot width is less than canvas dot width. That means as long as it's still on the left side of your canvas and hasn't gone past it. And down here, you want to make sure that the left side of your picture, which is just your x coordinates, so this dot x, is greater than 0, because then that means it has not gone off the left side of your picture. And I have forgotten the double ampersand. You're about to find out how important it is to have your double ampersand in there. My inspection tells me there's an unexpected token on line 173. So I go into line 173 and I see that I have left out my ampersands. Okay. So now, when it reaches the edges of my canvas, it should stop. Those statements should become false, and it should stop moving there, just like that. Beep, beep, beep. Oh, I don't want to blow up. Remember, if I hit him, I will blow up. There we go. Now I can't go past my canvas on the right. Oop. And I can't go past my canvas on the left. Right? So now, let's give this little guy a way to defend himself. Let's do a function called shoot. But first you have to write function, shoot, open close parentheses, open close curly braces. And in this one, we're gonna need a temp image again, or a temp shot. We'll say temp object is what I'm trying to say. So we say let temp shot equal make image. And for this image, we're going to be using a very small portion of our sprite sheet, just this little red kind of chevron here. And I happen to know that this chevron is 20 pixels wide by, or 20 pixels tall by 25 pixels wide, and it's at 50, 100, 150, 200, 250 on the source X, and 0 on the source Y. So I can come in here, I can plug all that in. Let me just put this as a placeholder so I don't forget to put it in there. But I want to put my source X and all that down first so I don't forget it. Okay, so I know it's at 250. I think I forgot it here. I'm going to check again. Oh no, I didn't. Okay, so 250. And I know its Y is at 0. And I know it is 25 pixels wide. 25 pixels wide by 20 pixels tall on the sprite sheet. This is in relation to the sprite sheet. And then right here now is where I will give it the shot type. Earlier I gave it hero, now I'm giving it shot. So this where do I want it on my canvas? Well, the width and the height's easy. I just want that to be small. So we'll say 10 by 15. Or, you know what, let's make it the same size as it is on our image, just so we don't confuse ourselves. So 25 by 20. The X and the Y, though, I want every shot to start right here at the beginning of my the gun barrel, or whatever you want to call it. So in order to do that, I need to pass it the hero.x plus hero.halfwidth, and that will get me to the same x coordinate as the exact center of my guy, my little hero. But then remember, it's a rectangle, so I have to come back a little bit, and I have to come back the half the width of my shot image, which it's going to be 25 wide, and half of that's really 12.5. So you can just write 12.5. And for the y coordinate, that one is just the y coordinate of the hero, because the y coordinate of the hero is the top, and I want it to be at the top center. So we can just say hero.y. Now I actually have to call this shoot function for anything to be shot. And I want to do that. Oh, wait, one moment. When I do shoot this, I want it to do something. So I have to give it an update. So you say tempShot.update. And I had a brain moment, and I'm not initializing this correctly. I'm initializing it as if it were an object. So instead of tempShot.update parentheses, you can write it like I have it here, and we're gonna come back and fix it. So write exactly what I have there, and then you'll get the same error that I'm about to get. And know that we're supposed to write tempShot.update equals function, and then open close parentheses. So down here, where we find out that we press the space bar, that's where you put the shoot. We want to shoot every time that we do that. Every time we hit the space bar, we want to shoot. So here it's going to tell me syntax error, unexpected token on line 159. So I go to line 159. And I find out, oh, yep, I definitely did that wrong. So it's supposed to say tempShot.update is equal to function, then everything else. Just like that. Okay, to be honest, I think I still have a mistake or two, because once I refresh, I'm hitting the space bar and nothing's happening. So that's why you see me inspect, and I don't see an error, so that means there's a problem with my logic. So if you'll bear with me, it takes me just a moment to realize what I'm doing incorrectly, and for any eagle-eyed viewers, you'll see I just passed it. When I call hero.halfwidth, that is a function, and I don't call any parentheses after it. I don't say hero.halfwidth open close parentheses, so it's not actually calling it. Still hitting the spacebar button and nothing's happening. You know, you could start to smell the smoke coming out of my ears. Double check my key handler to make sure that when I press the spacebar, I do indeed call the shoot function, like I do here. And then I think it's about here then I realize that I put hero.halfwidth and I don't call it as a function. Boop. So now, just put those parentheses in there. Now you're calling it as a function. And I have messed myself up, and if anybody else noticed, I accidentally put a space in a word. Instead of function, it says FUNC space TION. So if you'll bear with me just a little bit further, yeah, there we go. Function, not func, space, shun. Okay, so now that is working. Oops, I got destroyed. They don't do anything, and if you'll notice, even if I get destroyed, it still fires the shot. So we're going to do something about that real quick. And my first solution was inelegant and incorrect. so I'm not going to say much about it. Where I destroy my hero, first I say set hero equal to null. Because hero's still equal to something, it would just not in our array anymore, so it's not being drawn. But it's not like destroyed, it's just... And then down here, in case 32 of your switch case, you say if hero, and I'm trying to say if hero is not equal to null, or if hero is there. But it didn't quite work, because hero is still... It's still a variable, it's just now it's equal to null. So that's not working. So then I decided, okay, I know what to do. And I say if hero.state does not equal hero.hit, then go ahead and keep firing. And lo and behold, that was it. I'm pressing the spacebar like crazy and nothing's coming out. Okay. So now we have to actually add some bite to these bullets, and they don't do anything right now. So we have to go into their update, and we're going to check the little shots against... I lost my shoot function. There it is. Now we have to check every bullet against an alien and see if we've hit an alien. And we did it the same way we do with the hero and with other aliens, by setting a for loop to say for sprite of sprite array. And I commented out this.y is less than or equal to 7. I don't quite know why I did that. And it actually messes me up here in a minute. So you don't comment it out. So for sprite of sprite array, excuse me. And within that, I have to double check to make sure that sprite.type is equal to alien, because I only want to check against aliens. So say if sprite.type is equal to alien, then do something. And what I'm going to do is, just like all the others, I'll set a var, call it hit, and set it equal to hit test rectangle. And I'm telling you, it must have been super duper early in the morning, because you could see I misspelled hit test rectangle, and I didn't even put the equal sign. This will come back. You just keep following me, and we'll come back and fix this. So it will work, trust me. It's just going to give me a few errors before we fix it. So like the rest, I need to see that if hit.hit is true. And if hit.hit is true, I want to destroy the alien. And the alien I want to destroy is not this. That's the shot. I want to destroy the sprite. So I say destroy alien sprite. And then since I'm not running any kind of animation, I can just get rid of the bullet or the shot. I can just splice it out. So I call on sprite array, and I say sprite array.splice. And I need to send it an index, so I call sprite array again. And I say sprite array, send me the index, or sprite array.index of the shot. Now in this case, it is the shot, so we can say this, because we're talking about the shot that called this function. And then comma, I tell it to splice one thing out of the array. So now, every shot that you fire is going to check itself against every alien every frame, and if it's touching one, it will destroy the alien and then erase itself from your array, given the effect that you have blowed up an alien. And here's where I am learning all that stuff I told you a minute ago, where I needed to say var hit is equal to hit test rectangle, but I still don't realize that I've misspelled hit test rectangle, so I come back for seconds. And when I hit the pause button, it froze, because it's going to tell me here in the error that high test rectangle is not a function. I'm like, oh, or is not defined. I go, yeah. So there where it says on line 163, I put hit test rectangle, capital T. Okay, so you'll see there that it's still not working, but it actually is. I am firing the bullets, but this is where that commenting out of the line this.y is less than or equal to 7 came back to bite me. I thought maybe I had it in the wrong place, I was going to move it, and then I was like, oh, you know what? Actually, no, it was perfect where it was. It just needed to be uncommented out. So I put it back, and I just uncomment it, and there you go. Boom. Pew, pew, pew. Okay, So it's working. For the eagle-eyed viewers, you'll notice it runs through a couple of extra animations and it turns the flip-flop off on the other aliens whenever one gets hit. But it does work. You can shoot the aliens and they still move around and bounce off of each other. So congratulations on that. And in the next video, I promise, we'll go back through and we'll clean up some of these little small gaffes like this. I'll figure out what exactly the problem is and we'll go through and fix it. But besides that, congratulations on completing part 7 of this series. We now have a fully playable game. In the next video, we will wrap up the game build by adding a timer, a start and pause button, and a score. I hope you'll join me. You'll see me here. Actually, before I finish this, pardon me one last second. I try to fix one part by going into Make Hero and saying that, and I put it in the wrong spot. In shoot, if it's hit and this dot state does not equal this dot hit, meaning that bullet is not already hit. And then once it is hit, you have to give it a state of hit. So apologies for trying to end early there. This is one mistake that's been fixed, but there are still a few. You see they stop flip-flopping there, and we'll fix that in the next video, I promise. In the next video, we'll clean up these little ends. But again, you have a playable game. You can now play a game. You start, you can defend Earth, and you can shoot the little aliens. So I hope you join me for the next one. We'll be finishing up the game, really, and then the very final video, which will probably be part 10, that one is going to be bonus stuff. So really, part 9 should be the ending, and then part 10 is just, you know, how to make some extra buttons and stuff like that. Again, congratulations.